Yeah, I can't actually see when it starts recording now. Cool. All right, so we're going to talk through querying the fares data today. I think you all know that this is something I've been working on over the last 18 months, is building a journey planner. And what I would say is that I probably spent about 6 months working on the journeys, and that was relatively easy. And the fares, it's taken a little while longer. So what I'm going to cover today is just how to query the fares, and not the validation of journeys on particular fares and things like that, because that's a slightly larger topic all of its own. Yeah, and everything that we talk through here is implemented in the OpenTrack fares engine, and yeah, that's all open on GitHub, so you can have a poke around and look through it. I'd also say that there is no one true way of querying the fares. The thing that has taken me so long to even get like a basic implementation working just was understanding the data. But luckily, when I came to write it all down for this presentation, it's actually really simple. So it was just working it out that was hard. And yeah, but the actual doing of it is simple once you know what each of the bits is. So there's no one true way, but there is many incorrect ways, and I can run through how to avoid some of those. Cool. So if we run through the high-level process, then the first thing we want to do is fetch the flow fares, and I'll talk through what a flow fare is later. Then we fetch the non-derivable fares. We merge the two result sets together, and then we filter the results, and then we group them together for the passenger set. And so that's really it. And when you look through the code, you'll probably see that it's fairly representative of that high-level process. Okay, so flow fares. Basically, a flow is an origin, a destination, and a route code. So the flow fares are what I would describe as the standard rail fares for an adult. Okay, and yeah, I think that is kind of intended to be the default type of fare, shall we say. If you want to look up a flow fare, you need to find the relevant flow. So there's an FFL file, and it has 2 or more records inside of it. One is the flows, one is the fares. So the first thing we want to do is look up the flow, and to do that, we need to create a set of relevant stations for the query. So obviously, when we're trying to look up a fare, we want to see what it is between an origin and a destination, and I'm going to assume that they come in the form of an NLC. So to find the relevant flows for each origin and destination, we need to create a set that contains the original NLC, the clusters of that NLC, then the groups of that NLC, and then the clusters of those groups. So at this point, obviously you might be wondering, what is a cluster and what is a group? Both of them are just groups of stations. So they are like abstractions, and the clusters abstraction is purely used for these flow fares, and they effectively set a price point. And it's to cut down the size of the data. So rather than putting every single combination of origin and destination into the system, you know, they've essentially created particular pricing points of stations that are near each other, and then just used those. And the groups are actual group stations where you could travel to one or more stations. So that will be things like London terminals or Birmingham stations or something like that. And the end user never sees the clusters. Okay, so when your origin and destination is a cluster, you kind of map it back to wherever that cluster came from. But if it's a group, then you keep that group because it's perfectly valid to have a train ticket that goes to a group of stations. Anyway, it turns out that groups can be inside of clusters, so this makes your set of potential origins and destinations quite large sometimes. Now that we have these two sets of origins and destinations, it's just a simple lookup because the flow has an origin and a destination. The only thing that I would say is not so simple is that sometimes the flows are reversible. So there is a reversible flag on each flow, and if it is set, then you can check if your origin is actually a destination and your destination is the origin, and vice versa. Anyway, once you've got the flow, it's actually relatively easy. You can just look up all the fares for that flow, and those fares will be a list of ticket type and price. There is a status field in there, and we'll get onto status fields a bit later, but they're all adult prices, so it's all status 0. Cool. Oh yeah, I said we get to status discounts, and here we are. Yeah. So having all the adult prices for various ticket type codes is one thing, but if you have a passenger set that contains children or rail cards and these sorts of things, you have to apply what's called a status discount. And yeah, so children and rail cards are effectively the same thing. It's just a discount that you are entitled to by having a status. Yeah, and before we go and apply all those discounts, what we want to do is calculate all of the status codes that are in the passenger set. And then with each fare, we check for something called the discount category of the ticket type. So that's just a property of the ticket type. And then we look up what the status and the discount status is for that discount category, and we can then apply it. The status and the discount status effectively tell you how to discount the fare. The status itself will have the rules like 34% off, or you know, a maximum of a minimum of £10, and various other rules. And the discount status is actually like a joining table between the status and the ticket type that says, you know, for this status and for this ticket type, you want to apply the discount in this way. And they've all got funny names like L, K, and O, and these other things. But the most common one is a percentage discount, basically. Anyway, so when it comes to applying the discount, before you actually do apply it, you want to check for something called a non-standard discount. Now, every flow you get in your fares has a marker which says whether or not there is a non-standard discount on it. And effectively, a non-standard discount is an additional rule on a particular flow. So you might have, let's say, a standard rule for one ticket type and a status that says, you know, if you've got a child on a CDR, then you would discount it by 50% or something like that. But your non-standard discount might be set up on a particular flow to say, on this flow you discount it by 50% and then you add an extra £5. So again, non-standard discounting rules. There's a few different implementations of that. I think the most common one is that add-on amount, but there's a really complicated sequence of possibilities. Effectively, there is a non-standard discount file, and it has wildcards for almost every field in it. So it has an origin, destination, ticket type code, railcard code, route code, and something else I've forgotten. And each one of those can be null, meaning it applies to all of those things. And so you have to check through quite a lot of records to see if any of them are relevant to the particular flow and fare you're working with. So yeah, if there is a non-standard discount, then you obviously apply that according to the rules there. And if not, then you do the normal discount application. And at that point, this is a design decision that I made and other people have done differently. But I basically say that the application of a discount or a status to a fare results in a new fare. And yeah, that can in fact actually be 0, 1 or 2 fares when you apply it. If you have 0 fares, that might be because the rail cards, or I think the rail card is not permitted for that ticket type or something like that. You might have 1 if there is just a normal application of the status discount, but sometimes you have 2 if there is a railcar minimum fare. So you would basically have the full price discount and then also the minimum fare discount. Yeah, I think that covers everything. I'll just recap it because it's quite a lot of dense information, but essentially we work out all the statuses that are in the passenger set, we iterate through the fares, and then we try to apply the status to the fare, and that will mean either applying a non-standard discount or the standard sort of discount for statuses. Okay, so that's it for flow fares. You'll be pleased to know that non-derivables are much simpler. They sound scary and everybody worries about them, but they are actually much simpler. And that's because they are literally origin destination price. I'd also say when we're doing the query for non-derivables, you don't need to worry about clusters. It only seems to have the actual station NLC and the group NLC. It doesn't have any cluster NLCs in there. So that's our input set. One thing to note though is that they recently moved all of the non-derivables. They were previously split over 2 files, the NDO file and the NFO file. They've moved them all into the NFO file just for simplicity's sake. And as I mentioned, they are simpler, so they come with an adult price and a child price, and indeed a rail card. So you effectively don't need to do any status discounting or anything like that. These are fares that are specific, have specific prices set for, certain rail cards and things like that. And there is quite common for it to be used as a sort of suppression fare, and I'll run you through how that works a bit later. But what you'll find in the data is that there is a lot of sort of price of all 9s or all spaces or 0s, or basically a null price, and that acts as a suppression fare to say, if you're going from one particular station to another, let's just say you're going from Norwich to Tunbridge Wells, you can override the flow fare and say that with a particular rail card, it's essentially not possible to use that rail card on this flow, so you would give it a null price, or indeed a price that was not following the rules of the normal discounts. Yeah, I guess I would really describe these as hard-coded price overrides. Cool. Okay, so now that we've got our flow fare, ooh.
It's not only me. Oh,
yeah, sorry, I think my headset cut out there for a little bit.
Okay, so can you go back to the... Yeah, okay.
This one? Yeah, okay, I'll start from here. So yeah, now that we have the flow fares and the non-derivable fares, we basically need to merge them together into a single list of fares. And we do that by taking the origin, destination, route code, ticket type code, status and restriction code and forming like a unique key. It's just just an ID, and essentially the non-derivables take priority. So if you have a collision between the two sets, then you take the non-derivable. And as I said earlier, that's really just because the way the non-derivables are used is to override prices for normal flow fares and things like that. Okay, so now we have quite a long list of fares, and just to give you a rough idea, a London to Birmingham with adults, children, and a few rail cards can sometimes have up to 500 different fares in there. We need to filter the results to remove anything that is not actually valid. Okay, so the first thing we remove is those suppression fares. The reason, or another reason, that these non-derivables take priority over the flow fares is in case there is a suppression fare with a null price. Again, it just is a means of knocking out the flow fare. So there you go. Next one is the railcard ban. There is a record type which is the railcard restrictions, and it contains two different types of restriction. One references a restriction code, and I'm not going to cover restrictions with restriction codes today, but the other type is just a total ban. So a particular ticket type code might have a total ban on the use of a particular rail card. I can't think of any examples off the top of my head, but it would be something like using a young person's rail card on a first class ticket type. So those sorts of things will be in there. Next one is calendar restrictions. Every ticket type also can have specific calendars for when it can be used. These are pretty common. One good example is the weekender products. So a weekender product can only be out on a Friday and then back on Saturday or Sunday. There's a couple of different weekenders, and the rules vary, but it's something like that. And yeah, the calendar will actually say days of the week and some date bands and things like that, because they might ease the restrictions on bank holidays and other things, but it will tell you when you can and can't use this, so you'll need to filter things based on that. The next one is the advanced purchase booking horizon. Advanced tickets are typically you're only able to buy them the day before travel. So there is a set of data called the AP data, and that defines how far ahead it has to be for you to be purchasing one of these things. And I believe there are three ways that the data can specify it. There's the number of days, number of hours, and then I think it's a specific time. It's actually like a free-form text field that you just sort of have to work out. That may or well change in the future. They're talking about removing this advanced purchase booking horizon, but for now it's typically 1 day. Okay, then the next one is the validity code return dates. Okay, every ticket type has a validity code, and that validity code specifies the return date period. An outward and a return portion of a ticket can have specific periods. So a month return, you have to return within a month, but you could also have a day return that says you have to return inside of a day. On some anytime tickets, your outward portion has to go in the next however many 5 days or something like that, but yeah, your return has to be within a month. There's also a particular date has to have passed. and that's a rather interesting one. That basically says that if you are traveling, let's say out on a Monday, and the validity code says that you have to return after a Friday, then you can't return with that ticket until the Saturday. Again, the only use of that I've actually seen is with the Weekender, which specifies if you can only travel out on a Friday, and you have to return after one Friday, which means you can't return on the same day. You have to return on the Saturday or the Sunday. Yeah, it's maybe a little bit overcomplicated, but it's pretty flexible. Next one is the ticket type quote date. Every ticket type and many of the records in the data actually have like a start and end date, but the ticket types has an additional one, which is the quote date, which basically means you can't use it in queries until that date has passed. I'm actually trying to remember off the top of my head if that's the I think that's when you can start to query it. It's not when your travel date is. Yeah, it's when you're querying it. Cool. Then the next thing you would check is journey validity, which is a whole nother ballpark and thing of its own. Right. So now we have a long list of tickets that is most likely valid on those days that people have selected. What we need to do is take that big long list of fares and group it into the best combination for the passenger set we get. So we might have like 4 adults, 4 children, and a bunch of rail cards or something like that. And we need to work out what's the best combination of fares for that group. And turns out this is actually a slightly tricky problem. This is known as the assignment problem, and the sort of only algorithm I've seen that solves it is something called the Hungarian algorithm. Unfortunately, it's pretty slow, so it's order of n to the 4, which is pretty bad. But on top of that, it also uses a technique called dynamic programming. I'm not quite sure how many of you would be familiar with that. I'm certainly not, but yeah, if you've done any closure, you might be familiar with dynamic programming. It's some pretty crazy stuff. Sorry?
I think the backpack problem has the solution in dynamic programming.
Yes, so it's the same thing, basically, as far as I understand it. Yeah. And yeah, I mean, the complexity lies in the fact that there are so many different ways you could essentially assign the discounts. If you think about the variables being a ticket type has a number of passengers that can go on it. A rail card also has a number of passengers that could go on it, and there's various combinations of those things. There's also ticket availability for advanced products, and you have to factor in all of those things and work out what is the best way to assign these. And what I came up with in the end was a heuristic approach, which it just kind of means it doesn't guarantee that it's going to give you the best result, but it probably will. And the process I go through is obviously get the fare availability, then I actually divide the adult fares and the child fares and sort them by price, so the cheapest to first. And yeah, I essentially try to place the adult fares first, and then do the children afterwards. And that basically comes down to a situation where you have a rail card that can have either an adult or a child on it. You could use either one, and let's say you use the child fare and that saves you £1. Using the adult might save you £10. So the best thing for the overall passenger set would be to use the rail card on the adult rather than the child. And that's why at the very start here I split the adult and the child fares, is because I basically am trying to maximize the amount of discount I can get while still using the cheapest fares possible. Yeah, I think that's it. So it's probably quite a high level overview and maybe a little bit quick, but if you want to see any of the code, it's in this URL here. I would say most of the code is just loading data out of the database and turning it into something sensible. The implementation of all this logic is actually, yeah, pretty easy. If there's no documentation on this, which is why it took me so long to work out how it's supposed to be used, and I'm not going to claim that it's all 100% correct, but it seems to be mostly correct. So that guide there is the latest understanding of fares. If you did want to know about how to validate journeys, then you can check this project here. This JPath is essentially something that integrates journeys and fares and does that. And there is a separate document for that. Cool. So I think that's it. Any questions or any areas I should cover in more detail? Silence.
Do you stop recording?
No, it's still recording.
I have a question.
I'm-
That was
Okay.
quite at the beginning where
Yep.
you were talking about status discounts.
Yep.
So you said you can get two fares back.
Yeah.
One is a minimum fare discount fare and a full discount.
Yeah.
I wonder why you get two if you, I presume maybe that's my misunderstanding, but you can only use minimum fare discount.
Right. Yeah. So that is because the minimum fare discount will be, the minimum fare will be valid, I think, all the time.
Mm-hmm.
And the one with the full discount will only be valid after a certain time. And what you'll find is that the railcard restriction code specifies a time band, and that time band will be marked with a min fare flag to say, if you're traveling during this time, the minimum fare must be applied. So that's kind of why you need both, because at this point in your fares calculation, you don't know anything about the travel, specific travel times. You're just talking in dates. And that's maybe another thing that is not immediately clear, is that because this is just a fares engine, all it's doing is the most it can do without any idea of what the journey might be. So there is no travel time or anything like that. The only information we have is the travel dates and the passenger set. And I actually try to implement as much logic as I can in the fares engine, particularly with regards to these filters that happen, because this all these filters I can do on all of the fares for the whole day, whereas when I'm checking the journey validity, I have to do that obviously for every single journey, and it's really slow, particularly as my journey planner returns the full day's worth of journeys, which is like 100. Recalculating the validity takes a bit of time, so I try to push as much of it up as possible.
Yeah, no, it makes perfect sense. Thank you.
Cool. All right, I will stop recording and leave it there.